Section 5.5 is the law of sines. So this is the equation for the law of sines, and notice that it's for non-right triangles. And notice how you have sine of angle A over the side A and angle B over side B, and you can mix and match. You can use just sine A and sine B, or B and C, or A and C, but you have to make sure that their length, the side, is the denominator of the appropriate angle that you are taking the sine function of. Okay, so let's look at an example, and it'll make a lot more sense. So for case number 1, when you have angle, side, angle, or side, angle, angle, we are going to first start by drawing a picture. So if I let this be angle A, B, and C, we know that angle A is 63 degrees, and we know that angle B is 49 degrees. And the other piece of information we know is that side C is 78. So we don't know side A, and we don't know side B. So we need to solve for angle C and side A and side B. So since we're given two angles, to find angle C, we're just going to subtract the two we have from 180. And when we do this, we get 68 degrees. Okay, so to find a length, we are going to use the law of sines. So to find side A, I'm going to use the 63 and the 68. Now, we have to use 63 because, so sine of 63, we have to use that because we don't know what A is. That's our unknown. And this is equal to, the only other length we know is length C, which is 78. So we need to therefore use our new angle C, which is sine of 68. So we don't have much choice when finding the first side. So to solve, you cross multiply. And when you cross multiply, you get 78 times sine of 63, which is equal to A times sine of 68. To get A by itself, you divide by sine of 68. And make sure, since we're in degrees, you're in degrees in your calculator. So A equals about 75. Now when we do length B, we have some choice because now we have two sides, two angles. The only thing we have to do in finding side B is we have to use angle B because we need side B to be our unknown. So we have sine of 49, and then you can choose either of the other two, and I chose, again, sine of 68 over 78, which we know is our side for angle C, or side C. So again, follows the same steps. You cross multiply, so you're going to have 78 times sine of 49, and then you're going to divide that by sine of 68, and you get about 63.5. And now we have our whole triangle. Okay, so case 2 is when we have two sides and the angle opposite of one of those sides, so side-side angle. Now notice all the situations that we have. You could have no solution, which means the values that were given doesn't form a complete triangle. You can have one or you can have two, and this is how I say to start. You either have none or none or two. You just have to check to make sure your two work, and if one doesn't, then that's how it becomes a case where there's only one solution. What does that mean? Well, let's look at the next problems, and hopefully it makes a little bit more sense. Okay, so given that triangle XYZ we know that the side x is 1.5 centimeters. Angle x is 30 degrees. And side z is 2 centimeters. Okay, so the first thing that I'm going to choose to do is find angle z. So to do that, I'm going to use the law of sines. Or the law of sine, sorry. So angle z will look like this. It will look like sine of 30, because that's the only angle I have, over 1.5 equal to sine of z over 2. And when I do this in my calculator, I get sine of z, I'm sorry, do this meaning like cross multiply like we did before. So sine z equals 2/3. So to find z, we're going to do the inverse function. So we do sine inverse of 2/3. Now when you do this, we get 41.8 degrees. However, from previous sections, you know that sine, which is positive, in this case 2/3, sine is positive in 2 quadrants. It's positive in quadrant 1 and quadrant 2. The 41.8 represents quadrant 1. So we have to find the quadrant 2. And when we do that, for it to be in quadrant 2, like you know, we take 180 and we subtract 41.8 from it. So I have 2 possible angles for angle z. So this is where we can have 2 situations. Now, when I said check before, you have to make sure that the angle you're given, which was 30, plus your first angle, which in our case is 41, is less than 180, which it is, so we can proceed. And the angle 30 plus the 138 is also less than 180, so we can proceed. So both of these angles are appropriate. Both of these work. Okay? So we're going to continue solving like we have 2 situations. Now, in the triangle, what this means then is that we could also have a situation like this, where this is angle z and so is this angle z. Let me draw a little bit better. So it's a little bit more, it's wider here. So this new addition that I just drew is going to be the 138, and the one that was formed by that purple angle is going to be the 41.8. So that's this is how we have 2 angles to work with. Okay, so the next step is to find angle y. Now to find angle y, I need to do it twice. So if I have angle y, the first thing I'm going to do is subtract 180, or from 180, 30, and then first I'm going to use my 41.8. And when I do this, I'm left with 108.2. So if you notice in that triangle that I drew on the left, in red, it split angle y, and we have to solve for both of those. So for our second one, angle y is 180 minus 30 minus 138.2 now, and we get 11.8. So these are the 2 possible angles for angle y. And then we need to find our length y. That's what's left. So using this 108 now, I'm going to use the law of sine. So sine of 108.2 over y equals sine of 30 over 1.5. And when you crisscross multiply, you get y equals about 2.8 centimeters. And once again, we have to do it again and use our 11.8. So this would be sine of 11.8 over y equals sine 30 over 1.5. And again, we cross multiply, and this is where you get 0.6 centimeters for y if you use the angles 11.8 and 138.2. So here's a case where we have two possible solutions for our triangle. Okay, number 3. So in number 3, if we have QRS, we know that side S is 16, side Q is 20, and angle Q is 30. Okay, so first thing I'm going to do is find angle S. So I'm going to use the law of sines to do that. So angle S, I'm going to use sine of 30 and 20, because those are the two lengths and angles I have, equal to sine of S, which I'm solving for, over 16. And when you do this, you end up taking the sine inverse of 0.4. So since sine is positive, we can already foresee that we're going to be in quadrants 1 and quadrants 2. Okay, and when I plug this into my calculator, I get 23.6. Well, 23.6 lies in the first quadrant, so there's my first one. And when I find my second one to be in quadrant 2, I'm going to subtract it from 180, and I get 156.4. However, this is where you have to check. 30, the angle that we know we have, plus 23 is definitely less than 180. However, 156 plus 30 is greater than 180. So this is why I say there's always two, but that doesn't mean the two have to follow through. They don't always work. So this is where we can find two angles, but one of them doesn't work. So we're going to be left with just one solution. So continuing using our 23.6 only, angle R is going to equal 180 minus 30 minus 23.6, which gives us 126.4. And the last thing we're going to do is the law of sine for side R. So we have sine of 126.4 over R equal sine 30 over 20, and again you could have used the other angle, and then R equals about 32.2. Okay, so our last problem, we have a triangle JKL. J is 1.4, K is 2, and angle J is 45. Okay, so again, let's start by finding angle K. So with the law of sines, we have sine of 45 over 1.4, which is equal to sine of K over 2. And when I get this, I'm going to take the sine of K equals 2 sine of 45 over 1.4. Now, to involve a little bit of our recall information, we know that sine 45 is root 2 over 2. So, if we write 2 over 1.4 times root 2 over 2, 2's cancel. So we're going to do the sine inverse of root 2 2 over 1.4. So sine inverse of root 2 over 1.4. Now, before I even do this, root 2 over 1.4 is about 1.0102. And you don't necessarily have to do this, because if we know that sine and cosine can't be greater than 1, because we talked about this before. Your hypotenuse, it has to be the longest side. So if sine is opposite over hypotenuse, and you're dividing the longer side on the bottom, you're never going to have a value that you take the sine or cosine inverse, which is greater than 1. And since we are greater than 1, then it's not possible, can't happen. And if you didn't realize this here and went and just plugged in your calculator, you're going to get an error, and that is why. So k does not exist. This triangle is not possible. And that's the case where we don't have, when we have no solution. Okay, so from 2 points P and Q that are 140 feet apart, the lines straight to a flagpole across the river make an angle of 79 and 58 degrees. So with the line joining P and Q, what are the distances then from P to Q to the flagpole? So Q to R and P to R is what we're trying to figure out. So the first thing we need to do is find the angle R, and we would do 180 minus 79 minus 58, and when we do that, we get 43 degrees. Okay, so now let's use the law of sine to solve for, let's say, side P first. So to do this, I'm going to have sine of 43 over 140 equal to sine of 79 over P. And when I solve for P, I get about 201.5 feet. And then solving for Q, I can still use my sine of 43 over 140, but now I'm going to equal it to sine of 58 over Q. And after I cross multiply and plug that in my calculator, I get 174.1 feet. So those are the two distances from P and Q to the flagpole. Okay, so from a point A, the angle of elevation to the top of the tree is 38 degrees. So say this is A to the top of the tree, therefore with the base, if this is our ground, it makes 38 degrees. From a point B, 25 feet closer to the tree, the angle of elevation to the top is 48. So how far is it from point B to the top of the tree? Well, the other piece of information that we know is that it said 25 feet closer. So from A to B, we have 25 feet. So to solve A, or question A, I want to find angle C. Now, something else I need to add, which I forgot, I'm sorry. The height of the tree is right here, which creates a 90-degree angle. So, to find angle C, I need to therefore, well, I'm looking for, how far is it from point B to the top of the tree? So we're looking for A right here. So, for question A then, what we're going to do is we need to find angle C, which is at the top here. So to do angle C, I'm just going to subtract 180 minus 79. I'm sorry, I'm looking at the wrong one. 180 minus 38 minus 132. Now, where did 132 come from? Well, this is a supplementary angle, so since we have 48, we know we have 132. So this leaves us, angle C is 10 degrees. And I'm looking at the far triangle, so right here is 10 degrees. Not the whole angle C, just the sliver part from the black diagonal to the red diagonal. So either can you, now I have an opposite side and an opposite degree. 10 degrees is opposite of 25. And then I have A that I'm looking for and an opposite angle, which is 38. So I can use the law of sine. So I have sine 38 over A, which is equal to sine of 10 over 25. And after we cross multiply and divide, I get 88.6 feet. That is how far point B is to the top of the tree. Next, it's asking, how tall is the tree? Okay, well, now that I have side A, we just solved for that, and I have the opposite angle, and I have H, which I'm looking for, and the opposite angle. So I can just jump right into the law of sine. And yes, you can do the law of sine with 90 degrees. So I have sine of 90 over 88.6, which is equal to the sine of 48 over H, and H is about 65.8 feet. Now, the other thing to note is since it is a right triangle, we can use right triangle trig like we had been before. So you also could just do sine 48 equals opposite H over its hypotenuse, which is 88.6 that we solved for. So you can only do what's in orange because it's a right triangle, but you will get the same thing if you did it that way too.